The last example that we're going to take a look at here is example number 5. This one here is going to ask us to kind of demonstrate something that might seem a little bit strange at first. Suppose here that we have a function g that has variables s and t, but it's kind of weirdly written here. We could kind of almost imagine that maybe prior to this setup, I had a function g that had x's and y's, and it was some formula with x and y up here, but that something got subbed in for those x's and y's. If f is a differentiable function, show that g satisfies this equation. Okay, so I'm going to go ahead here and try to, again, think about my function g kind of like how I've specified here, that maybe it's really just a function with x's and y's that kind of got replaced. So I'm going to go ahead and say, how about we pretend that x is going to be equal to that s squared minus t squared, and y is going to be equal to t squared minus s squared. Again, this would mean that g was really just a function of x and y, and that when I replaced x with this formula and the y with that formula, I turned g into a formula with only s's and t's. Once I have this, I can start to see that it's possible to do a chain rule here. So I'm going to go ahead and compute out a partial derivative of g with respect to s, but also a partial derivative of g with respect to t. It seems like I need those pieces, and maybe if I have them, it'll be easier to see if and why this thing here is true. So notice here that my partial derivative of g with respect to s is going to be, well, I'd have to say my partial derivative of f with respect to x, and then multiplied by, well, my partial derivative of x with respect to s. So I guess that would just be times 2s. Notice since I don't know what the function f is, I can't really replace this first partial derivative, but I can replace the next one. All right, let's see what we get if we keep going. If I did my partial derivative of f with respect to y, I also don't know what that is, but I know over here that I would get negative 2s for the partial derivative of y with respect to s. If I now did a partial derivative of g with respect to t, I would see that that's a partial derivative of f with respect to x times a negative 2t plus a partial derivative of f with respect to y times a 2t. Okay, so I have these partial derivatives now, like I know kind of-ish what they are, but how in the world could I demonstrate that this equation is true? Well, let's just see what we come up with. If I just start multiplying what I have by the appropriate values. All right, let's just see what we get. I'll quickly write out here, note t times my partial derivative of g with respect to s plus s times the partial derivative of g with respect to t. Let's see what that becomes. I'm not sure if it's going to equal 0 yet, but I can start to replace items that I have and see what I come up with. So like here, I can go ahead and plug in my partial derivative of f with respect to x times 2s. And then here I'm going to write minus partial derivative of f with respect to y times 2s. I can then go ahead and do plus s times, let's see, partial derivative of g with respect to t. I'm going to go ahead and copy down what I had for that. Notice that's got a minus on it, so I'll just pull that to the front. And I have this. Now I'm hoping that this turns into 0 because that's what the problem says I should get, but let's just quickly see. If I did some distributing here, that would give me a partial derivative of f with respect to s, and then a 2st minus a partial derivative with respect to y, 2st, minus over here a partial derivative of f with respect to x. I can write that as 2s times a t, plus a partial derivative with respect to y, 2s times t. Oh, and look at this. A whole bunch of things start to cancel out. Right? Oops. It looks like here I just happened to have copied something down incorrectly. That should have been an x. Once I have that, you can see, yeah, these two pieces here are going to cancel. And of course, these two pieces here are going to cancel out. And so when that happens, I get 0. Questions like these tend to be questions that really scare people, right? Because you might have looked at this question and gone, I have no idea how I would possibly approach that. And honestly, the first time I look at a question like this, I don't have any idea how to approach it either. What I tend to do, though, is think about ways I could make the question easier to think through. Even though I don't know how to do it, I can still say, like I did here, hey, wouldn't it be great if I could just call these insides by a different name and rethink of the function? And then over here, I said, I don't know what this is, but I can at least calculate using what I know from the chain rule, these two pieces. And then I still had no idea what to do, but I said, well, I could just multiply these things and add them up and see what happens. And it just so happened that I got 0. I kind of didn't know that this was going to get me 0 until it happened. So this kind of just goes to highlight that you don't always need to know exactly how to do a question in order to actually arrive at a nice solution.